Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Grind 75, a Better Blind 75 coding series. So today's problem is on trapping rainwater. We have solved a problem similar to this previously as well in the series. So we have to find out how much water can be trapped in this, right? So let's just quickly jump into the problem statement, understand it and start solving. So last time we have solved the serialized and deserialized binary tree. You can find it in the list. We'll mark it checked. Let's start with trapping rainwater. Okay. Given n non-negative integers representing an elevation map where the width of each bar is 1, okay, compute how much water it can trap after raining. Okay. So we can easily understand it from the image example. So we can see these are the bars. This is the empty space. There's an empty space here as well, but since there's no bar on the left side of it, we cannot trap any rainwater here. And similarly, all these black points, they represent the bars, right? As we can see, 0, 1, 0, 2, 1, 0, 1, 3, 2, 1, 2, 1. Okay. Now we have to find out how much rainwater can we trap in this one. Okay. So the problem statement is very simple. So before I go on and start solving, please take a minute and think of an approach that you would take to solve this problem. Ready? Okay. So if you notice few things, the water that can be trapped, we can notice few things that it depends on the minimum height on either on the left side or on the right side, right? Like for this area, we can see the left side max height is 1, 2, right? And this one is 3. So we can store the water only up to level 3, right? And similarly, we can see for this one, we can see for this one as well. On one side it has 1, the other side it has 2, but you can only store till 1, right? Because if you pour more water, it'll just spill out, correct? So what else can we notice from this? So what we can do is we can one by one go check for the both sides and see how much water we can store, right? And then we also reduce these black points here. Like on the left hand side, the size height is 2. On the right hand side, the height is 3. We know 2 is the max height. And this length is 3, so 3 into 2, 6 should be the amount of water that can be stored. But then we have 1 and 1 black boxes here as well, so we should reduce that as well. So overall water stored is 1, 2, 3, 4, 5 and then 6. Okay. Now since left side and right side pointers are important, we can keep 2 pointers to keep count of what is the maximum height on the right side that is available, what is the maximum height on the left side that is available, and we will choose minimum of those height, right? Then at any point, how much water for that particular instance, like this one and this one, can be stored depends upon left, like we'll consider for this case, okay? It will depend upon left height, minimum of the two heights, okay? Left height or the right height. Minimum of the two height would be, left height would be 0, right height, let's say it is 1. So what is the minimum water that we can store? We can see 0 because there is no left side height available. Let's come to this one directly. So left side we can see 1, right side we can see 2. We'll take minimum of the 2, that is 1, right? Now we'll do 1 minus the value of or the height of this particular segment, and the height is 0, so 1 minus 0, 1. We can store 1 unit of water. Similarly, like this, on this, when we come to this block, we see the left height would be 2, right height would be 3, and how much water can we store? Minimum of the two heights, that is 2, minus the height at this bar. The height at this bar is already 1, so 2 minus 1, 1. We can store 1 unit of water at this single box. Similarly, when we come to this part, we can see 2 minus 0, 2 units of water, right? So it's a very simple approach we'll be taking. It's actually little difficult to understand, but once you understand it, it's much simpler problem. And I should mention it again if I haven't, that it's a really frequently asked interview question. Even I have faced this question multiple times in different interviews. Okay, so with this, let's start with the solution. Okay, first let's take our base case. What can be our base case? Let me just write it. Okay, so if height is equal to null, right? If height is null, that means this array, then we can simply return 0, right? Or height dot length is less than equal to 2. Why this? Because if you have only 2 bars, where will you store the water? For whatever values, you need minimum 3 bars, 1 2 3, to store the water in the middle, right? So we can say base case, no trapping water if height is null or less than 3, right? So with this we can say return 0. That's it. Now since we need 2 pointers on the left side and the right side, let's declare our variables. So left and right pointers. Int left is equal to 0, int right is equal to height dot length minus 1. Okay, these are the pointers, so that we can start contracting from the left hand side and the right hand side simultaneously. Well, of course we could use another approach where we go one by one, as we discussed. The one by one we check for the both height on each end, right? Or rather simply we take 2 pointers, one to traverse from the left side, one to traverse from the right side. And apart from that, we need the maximum heights that we have encountered. These are the pointers. Then we need variables to inform us of the maximum heights that we have encountered. So we can say left and right pointers for heights, or max heights, HEIGHTS. Okay, so we can say int left max is equal to 0. We will initialize it with 0. Int right max is equal to 0 as well. Okay, now of course we need one variable for the result, so int water trapped is equal to 0. Okay, now we will start with our iteration while left is less than right. So we'll check for few conditions. First we'll update our maximum heights for the left max and the right max. So we'll say update the max heights for or from left and right. So we can say left max is equal to, what will be the height of left max? Each time when we find a bigger height on the left side, we'll keep updating it. So we'll say math.max original value, that is left max, or height of left, right? So since the first is 0, we'll get the, and left max was earlier 0 as well, we'll get the first initial height of left max as 0. Similarly, right max is equal to math.max right max and height of right. That's it. Now right max was initially 0, but height right is 1, so its initial value would be 1. Okay, now we'll calculate the how much amount of water we can trap at any current position. Okay, so we'll say calculate the amount of water that can be trapped at the current position, current position. Okay, so we'll check if, since we have to take the minimum one, right, the lower one in the left max and the right max. If left max is less than right max, in this case that is true, right? Because that is one of the requirements that we can take. We have to take the lower of the values of the walls from each side. So if left max is smaller than right max, we can simply say water trapped is equal to or plus equal to left max minus height at left, right? And like in this case, left max is 0, it is smaller than right max. We see here it is 0, water trapped originally was 0, so we'll say water 0 plus left max, that is 0, minus height of left, that is 0 as well. So 0 minus 0, 0. So overall water stored is 0, or we'll keep the water stored here. Overall water trapped is 0 as of now. But since we have already considered this side, we'll move the left pointer. So we can say left plus plus. Else, now the left pointer moves and the left pointer is now here. Is left less than right? Yes. Left max is equal to math.max left max or height of left. Height of left is now 1. So left max got updated to 1. Left max is less than right max? No, they're equal, right? So we'll come to the else part. So we'll say water trapped. We'll use the same formula. Will be right max minus height of right. Right? So we'll calculate how much water can be stored on this point. So right max value is 1. Water trapped originally has the value 0 as of now. 0 plus right max 1 minus height at right, that is also 1. So 1 minus 1 is 0. So overall water trapped remains 0. But since we have considered this one now, so we'll move the right pointer in the inner direction. So right minus minus. Okay. Now, is left less than right? Yes. Left max is equal to max.max left max, which is right now 1, or left of height. So left height is now pointing at 1. Oh, we have moved this one, and the right pointer will be pointing to this part, right? Right max math.max to right max height or right, height of right is 2. So right max will get updated to 2. Left max is less than right max? Yes. So water trapped is equal to left max minus height. Left max is as of now 1. 1 minus height 1. This is 1. So 0. Water trapped was originally 0. We added 0 to it. It remains 0. Left pointer moved front. So we came to this one. Again, left max is equal to math.max left max or height of left. Height of left is 0. So left max remained 1 because we have a size 1 wall on the left side. Right max remained the same, considering that we have our 2 size height 2 available on the right side. Because even if you don't know these values, we know that at least at this point in time, we have on the left side we have 1 height, on right side whatever is the height, the minimum is the left height, right? So left max is lower than right max. Water trapped would be left water trapped plus left max, that is 1 minus height of left, that is 0. 1 minus 0, 1. So water trapped amount will increase from 0 to 1, and left plus plus, so now left will point to this one. Similarly, the loop will continue. I'll move forward with the dry run. So now left is pointing to the third, that is this one. Right is already pointing to this. So left max will get updated, and now it will become 2. We'll come to the else part. Since left max and right max are equal, water trapped would be right max minus height of right. That right max is 2, height of right is 2. So water trapped will be increased by 0. It remains 1. Right pointer will move forward to this point. Again, left max will remain 2, right max will remain 2 because we have a right max of 2 found so far. Left max is less than right max? No. So water trapped would be right max, that is 2 minus height of right. In this case, height of right you can see is 1. 2 minus 1, 1. It gets added to the water trapped. It gets increased to 2. Right minus minus, we come to this part. Then left max is same 2, right max is same 2. Okay, left max is not less than right max. Water trapped will get increased to right max minus height of right, that is 2 minus 2, 0. Height remains the same. Right minus minus, we come to this part. Now left max height would remain same, right max height gets increased to 3. So this is the 3. If left max is less than right max, yes it is. water trap would be left max minus height of left. So left max is at right now is pointing to this part, that is 0 1 2, this one. So left max 2 minus 2 would be 0, 0 gets added, water trapped is 2, left plus plus, left comes forward here. Now is left max less, left max will remain same, 2, right max will remain same, 3. Left max less than right max, yes, water trap would be left max, that is 2 minus height of left. Height of left is, in this case, 1. So 1 will get added to overall water trapped. So it will become 3, left plus plus, left will come to this part. Then again, same thing will happen, left max and right max will remain same, left max is lower than right max, water trapped would be left max minus height. So 2 minus 0, 2. So 2 will get added to the overall value, it will become 5. Left plus plus, left finally comes here, right is here, left max is same, right max is same, left is less than right, yes, water trap will get increased to left max minus height of left. Left max is 2, 2 minus height of left is 1. So 2 minus 1, 1 will get added to the overall water trapped and it will become 6. Then left plus plus. Now left is also pointing to this and right is also pointing here. So left is equal to right, left is not less than right. So the loop will break here. At this point in time, we have already found how much water can be stored. That is 6. So we can return water trapped, right? Let's quickly run it. Okay, great. Let's submit. Great, beats 100% of the users. Okay. I was thinking this is a very common approach. Generally, it is a common approach, but yeah, maybe some people wouldn't have taken this. But okay, great. So it's a very simple solution. You can watch the video again. It's a very simple solution once you understand it. It is from the hard category problem statement, and it is in fact a hard problem if you are unaware of the solution or if you have not seen it before. But once you understand it, once you know how we are solving it, it's a much simpler problem, right? Okay, so that's all from today's video, everyone. For anything, please let me know in the comment section, and in the end, please like, share and subscribe. Thank you.